Hey, hello everyone. Welcome to the session. Enoch, do you want to first give away the award or the prize to the person who has won the competition?
Sure, let me do that, but
Few people are asking Enoch on where can they find the quizzes. So I request three things to be done. One is we can share the WhatsApp number. We can write it by sharing our screen.
sure.
You can ask people to send a message to that if they are not on the WhatsApp group. Number one. Probably we will do it after 1 hour. And
Sure.
second thing is you please show them the link, Facebook link or LinkedIn link. That too we will do it okay, mid
All
of the
right, but
session so that everyone has a look at that. And then you can proceed further with the quiz. Yeah.
sure. So let me quickly share my screen. So on Friday morning, we put up some quiz questions after our session, and about 183 people gave the answers. They have commented their answers. So out of this 183 people, we are going to randomly pick one person, and then we are going to give them a surprise gift. So I'm going to use Google's random number generator. It is a tool which generates a random number when I click this button. So I'm going to put minimum 1 and one maximum is 183. So just to re-verify, the final number is 183. So the moment I click on this generate button, whatever is the number that comes here, that person is the winner of our lucky draw. So without any further delay, let's do this. 3, 2, 1, and go. So it's number 21. So let's see who the person is. Number 21 is John Messia and Das. So John Messia Das, congratulations. You are our winner for today. And our team will get in touch with you and we'll share with you how we will give you the surprise gift. And congratulations once again, John Messia Das. And we look forward to talking with you very soon.
Congratulations, John, on competing in this competition and winning a place. It means a lot. You guys have been very, very interactive on social media. Yep. And great job done. We all should serve as an example because we are in the world of digital transformation. And yep, thank you so much. Good job done. All right, let me share my screen now and we shall proceed further. Hello, everyone, and a warm welcome to the session. We are, as part of today's discussion, going to spend our time on recurrent neural network. We had ample discussion on computer vision aspects and then convolution neural network, right? And now we are going to switch gears to recurrent neural network, wherein we are going to deal with textual data. So let me do a quick recap because there was a weekend in between. I want you all to come back to the learning groove. CRISP DM, which stands for Cross Industry Standard Process for Data Mining, has 6 stages. Number one is understanding the business problem. Once you understand the business problem, you need to record the business objectives and business constraints. Then you proceed further with data collection. As part of data collection, one should be aware of the various data types, primary and secondary data sources. Then you proceed further with data cleansing. There are bunch of data cleansing, which is also called as data preparation, data munging, data wrangling, bunch of those techniques. And then you proceed further with data mining or machine learning. Before we take that route, we have to understand about mathematical foundations, and we have done fair bit of analysis on data optimization. Then we moved on to deep learning primer, wherein we understood about the entire deep learning, what are the various libraries, optimization, so on and so forth. And then we have deep learning challenges and practical issues. And we need to be aware of all the regularization techniques as well: early stopping, dropout, drop connect, so on and so forth. Once this is done, we also need to be aware of deep learning primer. What do you mean by deep learning? What are the various components? What do we have in an artificial neuron? What are the various activation functions which exist? Right? What are the various optimization techniques which exist? And we are going to update this mind map even further. On a daily basis, we will try to update on the weekdays. Today is no different. We will spend time. Okay, so we have black box techniques, neural network, in which we have discussed about perceptron algorithm, multi-layered perceptron, convolution neural networks. Okay, and then we have all these various layers in CNN. Okay, and we learned about a lot of things such as how do we build a practical CNN, right? What are the model building steps which are involved? What are the advantages? Okay, so on and so forth. Now, and even before that, we spend a significant amount of time on computer vision, significant amount of time. We understood the challenges, what features you can extract, what image operations we can perform, so on and so forth. And now we are here at recurrent neural network. Theoretically, we will discuss a few things. Practically, we will solve a few things. Okay. And in the interest of time, for certain algorithms, we will be theoretically discussing all of these. Okay, but let us get into recurrent neural network, which is one of the most widely used algorithms in the space of unstructured textual data. If you want to deal with unstructured textual data, then people heavily use this. So even before we proceed further with this, I want to quickly explain about a few text mining aspects because that is going to set the tone for the rest of the sessions. So let me go here. Text mining we have covered for a few sessions. Yep. So we will quickly discuss about text mining, how it works, and how deep learning is revolutionizing text mining and natural language processing. So this will be all theory for probably whole of today. We'll be discussing only about theoretical aspects, and then we'll proceed further. Okay. Welcome to the world of text mining and word clouds. So these are the kind of visualizations you can plot using text mining. And the first thing is roughly 80% of the data that we work on is in structured format. When I say structured, you have data in a neat tabular format in rows and columns. That's called as structured data. Only 20% of the data on the planet is in structured format. Remaining 80% of the data is in unstructured format. And what are the various avenues of unstructured data? You have videos, images, audio files, speech transcripts, and textual data. Videos are nothing but collection of multiple frames of images. What that means is when I say we have worked on images, indirectly it means we have worked on videos. Because the moment you have a video file, you are going to split that video into multiple frames of images. We have already completed this portion. We have done it pretty exhaustively. And we'll also touch upon briefly how to deal with audio files. But now let's get into textual data. What kind of data is called as unstructured textual data? Call transcripts. I mean, if you get a phone call, you would hear this message that the phone conversation would be recorded for training and quality purpose. You keep hearing this, right? When you call center or when you receive any call from the call center, sometimes you hear that. So what happens is usually people convert data into speech, speech to text, and then this text would be in unstructured format. You analyze this data. Emails which are sent to customer service would be in unstructured format. Social media outreach would be in unstructured format. Speech transcripts. If Narendra Modi is delivering a speech, or if Jagan is delivering a speech, then someone would have written the speech transcript and given it to these people who are at high profile. Field agents, salespeople, interviews, surveys, all these will give you a lot of unstructured data. Field agents will go and capture the data by interacting with the people. Salespeople interact with the customers. They get a lot of data. All this is in unstructured format. And when you have data in unstructured format, you can actually represent that in a structured format. How do you do that? You have the word world, which is appearing once. The words such as all, the, apostrophe S, A, and all these words do not really make any sense. These kind of words are called as filler words. Just for English sentence formation, we use that. Filler words, connectors, okay, stop words. These words just are used to establish grammatically correct sentence, but they on their own do not have any value. The word stage is appearing once, the word men is appearing once. And okay, question to you all, where is the word appearing again, men appearing again? Because I see that it's appearing twice. Yeah, please can you comment on where else are you seeing this appear twice? Is it appearing twice? Yes. But if your answer is women, answer is no. That's wrong answer. Because women is also appearing once. So my question is, where is it appearing the second time? If you all are able to see this correctly, yes, man. So singular or plural doesn't matter. Okay, it doesn't matter basically. So you convert that or count that as single word. So this word is appearing twice. All right. Then if you look at this word play, where does it appear twice? Observe carefully. Can you all respond? Yes, it is appearing here in players and plays. Here you are using the base word, base form of the word, which is play. To this play, if you add ing, it becomes playing. To this play, if you add ed, it becomes played. To this play, if you add ers, it becomes players. So on and so forth. So the word play is appearing twice. It's appearing here and it is also appearing here. Then you have exit, and then you have entrance, time, all these are appearing. This is an excerpt from Shakespeare's play As You Like It. William Shakespeare, right? Famous writer, author. He has written a play. You can think about that as a book, maybe, called As You Like It. From that, this has been extracted. If you give these three lines to an English professor probably will spend another 3 hours just explaining how beautiful and how amazing these three lines are. But then, if you supply the same unstructured data to a statistician, what will happen? Statisticians, mathematicians, economists, data scientists, AI experts, they will simply take these three lines, they will break it down into a representation which is called as bag of words representation. And each word is appearing once. This is a way of converting unstructured data to structured format. Each row of unstructured data, each row of review is called as a document. When you conduct a survey, for example, say you're conducting a survey which has all these questions, question 1, question 2, question 3. In this way you have the questionnaire, and say 10,000 people have responded to your survey. Out of these 10,000 people, you cannot expect everyone to respond to each and every question. Say you have 10 questions in total. A few people might answer the top 5 questions. A few people might answer 1, 3, 6 in that way, whatever is relevant for them, right? And say you have a question here which says, how was the training? How was the training? Please elaborate. Okay, how was the training? Please elaborate on that. If this is a question, then not many people would like to elaborate. If there's a rating scale, on a scale of 1 to 5, rate this, you all might rate some number. Okay, 5 being highest, you'll rate some number. But then if a follow-up question is asked on please elaborate on what you liked in the training, then we cannot expect all 10,000 people to answer. Maybe only 6,000 people would have answered that. Another 4,000 people did not answer. So when you collect this data, person 1, 2, 3, all these 10,000, for this question 4, question 1, 2, 3, 4, for this question 4, in 4,000 places you'll have empty cell. This empty row that you are observing here is also called as document. So each row of feedback that you collect is called as a document. Even if you have empty rows, it is called as a document. And collection of all these documents, all these 10,000 documents, is called as a corpus or corpora. Corpus is singular, corpora is plural representation. Okay, remember these terminologies are very, very important. And next thing is, we need to understand the quirks of languages. For example, sometimes people might, misspell the words, such as this should have been music, M-U-S-I-C, but it is M-U-S-C. Okay, and then we also have terms which are in lowercase, proper case, and uppercase. All these should be converted to a common case. All these should be converted to a lowercase, or all these should be converted to proper case, or all these should be converted to uppercase. Otherwise, your system is going to treat each of these words as a different word altogether. So it will treat this as a different word from this. And when you have punctuation marks such as percentage, exclamation, ampersand, etc., these might not really make sense. You might want to remove that. Data pre-processing or data cleansing, however you want to call that. We will usually get rid of that. Filler words, connectors, pronouns doesn't add any value. So you might want to get rid of that also. Then you have something called as stemming. Stemming is a process of considering only the stem words like jumping, jumped. Okay, stem word here is jump. That's going to take this to the base form. Okay, Let me show you Amazon customer reviews. Of course, we are not going to work on that, but just to give you a sense on what kind of data people extract. My reviews of, say, Kindle. If I were to open this is a Amazon Kindle product. Look at how many reviews we have. 7,922 customer reviews. This is one review. This is another review. This is a third review. This is a fourth review, fifth review, sixth, so on and so forth. And if I click on next, I'll move to the next page. 11 to 20 reviews are in this. If you again click on next, look at how lengthy these reviews are. Do they write such lengthy reviews? Oh, yes. Who are these people? They want themselves to be identified as tech geeks, technology early adopters. If someone keeps writing such lengthy review, they will eventually be recognized as tech geeks. The moment someone recognizes them as tech geeks, they would be invited to all the tech forums. And if Amazon is going to launch a new version of Kindle, new Kindle product, then they would certainly invite these kind of early adopters and tech geeks, and they will have them do thorough testing. Okay, that's the kind of benefit. Hence, people write such lengthy reviews. You have this is page number 3, and you have 21 to 30 reviews in this. Now, if I proceed further, then you have here page number 4, and you have 31 to 40. In that way, how many pages will you have? Umpteen number of pages, and all these reviews. Can you manually go and read each and every line and figure out what are the positive things which people are speaking about your product, and what are the negative things which people are speaking about your product? Can you make any sense? Can you make out any sense by reading line by line? Can you do it manually? We cannot do that, right? Manually, we cannot do it. First thing. Second thing is, how do I extract the data? It really depends on whether your website is built on Java or .NET or PHP or HTML or there are a bunch of other web technologies. On which technology your website has been built, it purely depends on that. So if I were to right click and say view page source, okay, I have this page source. So I'll go here. You just copy this portion. I have used Kindle since shortly. I'm just copying this part. Control F and V. There we go. So what happens here is, for each and every review, you will have this HTML tag on what is the start. You have to give a mark Q. You have to say that this is the start of all reviews, and what is the end of each and every review also should be identified. Probably this is marking the end of the review. Take any review. This will be the start and end basically. So if I take this, I bought Sony whatever. If I were to replace it here, look at that. Once again, what's happening here? The start remains the same. End also remains the same. You have the same end and same start. So you tell your computer, your statistical programming tools, R or Python, that extract all the text which comes in between this start and end. Extract this entire text which comes in between the start and end, and then you perform text mining on that. Okay, so we have in the past extracted all the reviews of Xbox. Okay, and then we have collected all the reviews. And what did we do? We have performed something called as document term matrix or term document matrix. Document term matrix means documents will be on the rows and the terms will be in columns. All the terms which are used, all these terms would appear. And this is the first review which you see. And this first person has referred to the word keyboard 4 times. This first person, when this person has given review about this product, he has used the word USB 1 time, free none of the times, hard was used twice. Person 2, when person 2 has given the review, keyboard was used 3 times, USB was used once, free was used once, hard was never used. So on and so forth. You have reviews given by 100 people. 100 people have given the reviews. And if you count all of these keywords, you get 200. Right? The word keyboard is appearing 200 times in 100 documents. So question to you all is, how many times does it appear in each document? Yep. Please can you all answer? Let me put this as a poll question and let me have you all answer this. So I'll go to the poll question. Here's a poll question. If a word appears 200 times in 100 documents, then how many times does it appear in each document? Yes, please. Can you respond? Yeah. If a word appears 200 times in 100 documents, how many times does it appear in each document? Please, can you all, I request everyone to respond to this poll question that I've asked. Wonderful. 2 times. That's a good thing. That's a good answer. Just a moment, please. Okay. So here, it's so very easy. If a specific document is appearing 200 times in 100 documents, then in one document, it appears twice on an average. Okay. Let's look at USB. If the word USB appears 50 times in 100 documents, if a word appears 50 times, then in each document, how many times does it appear? 0.5 times. Half times. If the word free appears 100 times in 100 documents, then on an average, how many times is it appearing in each document? 1 time. This is called as document frequency. And this count is called as term frequency. Term frequency, TF. Term frequency. Okay, then the more the number of times a word has been referred to, the bigger the word would be. The in this word cloud, I mean, you are representing these term frequencies of each and every term in a visual manner, and this is a visual representation of your terms, and this is called as word cloud. It appears like a cloud of different words, hence it's called as word cloud. Here color has no significance. Okay, color does not mean anything. Size, yep, more the term frequency, more the term frequency, bigger the terms. Bigger the words. So game, music, so on and so forth. Wonderful. But then certainly your Xbox manufacturers, people who have been manufacturing Xbox, would certainly ask you this question on this is fine. We all know that it's a gaming console. We all know that we can play music. But what is the new insight that you're giving me? Right? If you throw this at them, they will say, give back my money. I've paid you 10 lakh rupees for consulting. I want that money back. I know that this is a gaming console. I know that it plays music. What is the new thing that you're giving apart from this fancy plot? At that point of time, you'll say that customer, hold on. We have done additional analysis, which is nothing but sentiment analysis. Sentiment analysis is all about capturing the emotions of the people. Wherein you're going to capture positive and negative emotions. For this, what you do is you take your data that you extract from social media or from Amazon, one of those places, and you make use of, if it's English, you make use of English dictionary. And you compare each word with this English dictionary positive words. You can just download from internet positive and negative word list. Let me show you that. I think we should be having that. Yep, here we go. Positive words. So these are all the positive words from an English dictionary. Take all these words and at the same time also make use of negative words. These are all the negative words which appear in English dictionary. And then you try to compare each word which appears in your review with the positive list, positive word list, as well as negative word list. If there is any word in your reviews which matches with the positive list, it appears in this word cloud, which is called as positive word cloud. But then out of all the different words that it is very silent, okay, and then free is catching the attention. What do you mean by free? Now we really don't know what free means. So you have to go back and read this in the context. So here are the Xbox reviews, which have been extracted from Amazon. Okay, just to show you all. If I do Control F and if I type free, it would show you something. Look at that. It says 7 GB of storage is free. And then where do I have now? I think I'll go to the top and then I'll once again run it from here. Where is it going? Yeah, 7 GB of free cloud storage. What is free? What is free? Yeah, 7 GB of cloud storage is free. 7 gigs of cloud storage is free. Now, this is what is interesting the people. If you give this insight to Xbox manufacturers or to Xbox marketing team, they will say that, okay, everyone is happy with the free 7 GB cloud storage. So we will continue providing the free storage. We'll continue this free storage process. At the same time, people will also ask you on what are the negative things which people are unhappy about. And when you do a negative word cloud, you take all these reviews and give it to your computer, to your algorithm, which will then compare all these words against a negative word cloud or the negative words rather. And if there is any of these words appearing in this Xbox, then you'll have a word cloud like this. And here you have hard. Hard means the gaming console keys are hard. So if you give this insight to your Xbox manufacturers, they will ensure that such issues are addressed. Overheat. So you go give that feedback back to your Xbox manufacturers so that they might fix this issue. So in the next version of Xbox, they will ensure that the keys are softer, not hard. Okay. And then I also want to explain you all the importance of doing this, wherein you go to Twitter, and usually who tweets on Twitter? I mean, today, do you know what? I'm not sure whether you have seen this or not. Narendra Modi has crossed 6 crore followers on Twitter. 19 hours back story. PM Narendra Modi's Twitter followers rise from 5 to 6 crores followers. Prime Minister of a country is so active on digital forum. It's really amazing times that we are living in, that we have Prime Minister of the nation who is supporting digital transformation in a big way. A person who is of probably 65 years old age has taken upon himself this particular responsibility of motivating us to have social media accounts. And what are we are, I mean, given his busy schedule, we are nothing, right? So we all should be having an account. Why? I will tell you. Because we will be training our future generations, and we cannot set a wrong example saying that we don't want to have an account, social media account, right? And that's why we are very keen from our side that we will do our bit for the country, for the society, and we will be giving a few things on social media only. If you have an account, you can access. I request you all to support in this good cause. Okay, so why am I saying this? Let me tell you. Do you know what? Social media analytics is a very big thing, as I keep saying. What has happened here? Why is it not coming up? Sorry. Is it something that Twitter is not allowing me? All right, let me close this and open this again. Yep. So on social media, we do celebrity analytics. I can show you that right away if I have it open somewhere. Yeah, here it is. Okay, social media analytics and celebrity. Yeah, celebrity analytics. So what we have done is in the past, we have extracted the data, social media data of the celebrities, and we have done analytics. I can. Okay, I think there'll be slightly client sensitive data. So that's there in the drive here. Anyways, I'll see if I can download that and show you at a later point of time, only if time permits. Okay. And what is your take, friends? How much do you think celebrities get paid when they tweet? Or let me open Virat Kohli payment on each tweet. Okay. So you can just give this. Look at this. How much does he get paid? 2.5 crores per tweet. 2.5 crores per tweet, because despite being athletes, they're also active on social media. They understand that we have to be active on social media. We also have to understand, because we'll be training our students on social media analytics. Next thing is there is something called as Nestle Maggie Fiasco, which has happened. What happened? There was 3 years of ban on Maggie noodles. Do you know how this triggered? Someone resorted to Twitter saying that if you consume uh, Maggie, there is excess lead content in it, which is going to damage your health. That was good enough for everyone. Negativity spreads like wildfire, right? So everyone resorted to this negative tweets, and thereby resulting in 3 years ban. Means a lot of money lost. From there on, people started doing risk sensing. Risk sensing became very big project in the space of social media. So all these big players, they started extracting the data from social media, and they started doing risk sensing. For example, periodically every day, the project that I worked on, every day we used to extract the data of various products of Nestle, and we used to generate such negative word clouds and positive word clouds, and we used to share it with the decision makers of Nestle. If they see anything bad going on, they would quickly jump in, make a press announcement, and try to subside that particular issue if it is not true. Sometimes competitors want to, resort to that, mechanism to destroy the competition. They cannot directly take head on, so they resort to negative ways of, handling this. And what you guys have to do is open Twitter, create your Twitter account, and there is something called as Twitter apps.twitter.com. Apps.twitter.com. Why is this? Okay, I didn't type it properly. When you open this apps.twitter.com, you would see something called as create an app. Click on that, create an app, give a name to the app, give application description, give the URL name. You can just copy maybe 360 digit MG URL. You just go copy that URL here and then job done. Okay, and put your URL here. A callback URL also can be the same thing, doesn't matter, make sense. You give whatever it is and give an explanation on why you want to use this. You can just say that you want to do risk sensing, and you have to give a reason on why you want to use it. You can just say you want to use it for risk sensing purpose. You want to track your organization products and services. Once you complete this, you'll be rerouted to this page wherein you'll have your app. We created one app to look at the details on IPL. So if you click on details, you'll be going to this page wherein you can click on keys and token, and these keys that you're seeing here, API key, API secret key, access token, etc. You take all of those keys, give in your program, and you will be able to extract reviews of any product or any company or any celebrity. So you can do risk sensing of your organization, of your products, of your services. You can do customer analytics. You can do celebrity analytics. A lot of things you can do. If someone is going to pay Virat Kohli, for example, 2.5 crores per tweet, then they would be doing maximum analytics possible. That's a big field. And you all and we all together have to explain to our students that these are the various career opportunities that exist. And for that, first of all, we have to have accounts. Right? We cannot thrust these things down the throat of our students while we do not follow one. Right? I request you all once again, right? Be part of that. Our Prime Minister is part of that. Why can't we all be? Yeah, I request you all once again to do that, because a few people were saying we don't want, we are strict on that. I don't know why you're so stubborn on that, but that's a request from my side. Please do that. Why? Because again, I'm showing you, I'm trying to motivate you all here. Okay, so here we are going to resort to R programming, and I'm going to show you on how to extract the tweets from Twitter and how to come up with a word cloud. Okay, and you can also extract the data from Facebook. You can extract the data from LinkedIn. However, to be able to extract data from Facebook and LinkedIn, there are a few additional steps. It is not as straightforward as we have for Twitter. Okay, for Facebook and LinkedIn, it's slightly different. For that case, you can also extract the data from Google Maps. Amazing things is what you can do just based on social media analytics and web extraction. Okay, so we have a library called as TwitR. Okay, you install that and invoke that. There is another library called as RO authentication. It is used to establish authentication between your R program, R tool, and Twitter or any other softwares or any other social media forums. You also have base 64 ENC. Each time there is a new package, and if you're not aware of that, you just type base 64. Tools for base 64 encoding. Okay, you convert the data which is extracted from social media into a common format which your computer understands. HTTP UV is again used to establish the connection, right? It uses something called as WebSocket server library. Then here, this is very important. Please pay attention. You have the consumer key. Here you need to give your consumer key. Here, API key. Just copy that and go and paste it here. Then you go here, API secret key, copy that and paste it here. Then you give the request URL, access URL, and authentication URL. These three URLs can be the same. Do not change those URLs. And whenever you paste the key, ensure that you do not have a space at the start or at the end. Then you run this. Store these credentials in a file. Save those credentials and load that whenever you want to. I'm just showing you that you can save and load it whenever you want to. Okay. Now again, the same consumer key would come in the first place here. The same consumer secret key would come here. And there are two more keys that you need to supply. How would you supply that? Go here and you have something called as regenerate, and you copy this access token, paste it here, and copy this access token secret key and paste it here, and then run this code. Here it will ask you a question on, do you want to use direct authentication or not? You have to always say yes. Then it will establish the authentication. Now let me go to Twitter. Let me extract reviews of Sachin Tendulkar. Twitter account. What is his Twitter account? @Sachin _ Ramesh Tendulkar RT. So let me copy that and let me paste it here. And you're saying you want 1,000 lines of reviews to be extracted or tweets to be extracted. User timeline, go to Sachin Tendulkar's timeline and extract those. You can extract anyone's tweets whatsoever. So look at this red symbol. That means it was establishing connection with Twitter and it has extracted the tweets. If you convert the tweet list to a data frame format, then you'll be able to see the tweets. If I run this, I'm just converting it to a format where you can view. Look at that. All the reviews written 19th. Yesterday also Sachin tweeted twice. Okay. These are all the reviews which Sachin Tendulkar has written. Okay, and then what would you do with these reviews? You are interested only in this first text. Right? Recently, he has also commented about the West Indies team winning against England, and he has commented about the partnership right? That's amazing thing. And you're interested in only this text, so you'll take that. Tweets df dollar text will refer to only this first column, and then you save that in tweets raw. And these tweets, do you know what? You can save it to your computer. So you're saying, okay, I want to write these tweets in a file in the format, and the file name should be tweets.csv. And then you have get working directory. So it is there in downloads. Let me go here. Do we have it here? Oh yeah, it's there today at 11:29. Okay, I think it's break time. Anyways, we'll take a break in a minute. So here we have tweets. Look at all these tweets that Tendulkar has done. But then it has a lot of special characters like this, if you observe. Right? All these special characters exist. You do not want such special characters. You want to delete those. You want to get those deleted, right? And AMP, all these other special characters basically, which your system could not understand. So we will have to do some kind of data cleansing here and then come up with the word cloud. Okay, we will do that so that we understand how to traditionally use techniques, and then we will certainly resort to deep learning techniques to see how it works. Okay, so break time. Let's take 10 minutes break and then come back, and then we will generate a word cloud. So it's 11:30 now. Let us be back by 11:40. Until then, it's break time. Okay, are you all there? Yep, thank you so much, friends, for giving us good feedback. All right, so couple of things before I proceed further, since you all are here. I think it makes sense to quickly write it down here because I've got requests from three of the professors saying that we also need the hands-on and assignments. Hands-on, I'm assuming you're requesting for the R code and Python code. Yep. So this can be uploaded on the learning management system. So I can tell you upfront that we will upload in the learning management system. Okay, this is one thing that we will do, certainly. Okay, how about datasets being used? Datasets will be put on GitHub, and we shall provide access to GitHub, or we will provide the link. Okay, we will post it on the WhatsApp group. Enoch, if someone is not there on the WhatsApp group, what is the link? What is the number? Can you just let me know?
I put it on the sticky note. You can just copy paste it, but
Okay, sure. So if you're not there on the WhatsApp, you can send a message to this. Please WhatsApp on this number if you're not part of that, and we are going to add you to this group. So these two issues of hands-on material and datasets is done, but it will take time. Okay, don't expect rocket speed responses from us because we are also handicapped with a lot of projects. We have got lot of projects from Coca-Cola, from um, a lot of startups and many companies. So we are working on those projects. Our team is extremely swamped with a lot of tasks. So I don't want to put any additional pressure on them, but it will be done. You'll have LMS access will be there for next 6 months. So you can view it. Okay, do not worry, you can view it. So on a learning management system, already the slides are there. So let me put it here. Are already available on quizzes for your own practice. Quizzes are already available on LMS. You can take those quizzes. Only thing is, don't try to replicate it. If you try to use the same things for your own training purpose, it is not done. We don't want to give any exclusive rights to anyone whatsoever to reproduce our training slides or our quizzes. Okay, please don't do that. We actually take it on a serious note, and we do not entertain that because it's our 7 years of hardship. Okay, so we don't want you guys to resort to those kind of practices. I'm sure you won't, given the maturity that you have, but still, I'm just putting a caution note. Okay, next thing is assignments. Okay, what we thought about assignments is we do not want to give it to people who are not serious learners, but it will be provided to serious learners. Absolutely. But how do I decide? How do we decide on whether you are serious learners or not? We are going to decide upon conducting an exam. So any day, any day after you complete the training. It will be open. So we will be creating a website link for the exam, which will be multiple choice and certain Python programming questions. Okay, which will be subject to you have to write this. And if you get more than 70% marks, then you have to drop a note to directly me. Okay, I will directly look into it. And immediately all assignments will be provided to you. Okay, so that means we first of all, even before you go to the assignments, the objective here is to ensure that you learn on what is taught already. If you watch all these videos and if you can run the program at least once on your computers, you will be able to get 70% marks. Then you simply drop a note to me immediately on the same day. All the assignments will be provided to you. Okay, not just that, we will also guide you on those assignments. Our team will guide you provided you get more than 70% marks. I believe this is a fair thing. Already I'm stretching myself. I'm giving you hands-on R code, Python code, data sets. Everything will be provided. It'll be posted on the WhatsApp. If you're not on the WhatsApp, please message us. We will take it further. Assignments is for serious learners only because we don't want people to misuse the assignments, because we have a lot of client data also which exists. We have taken special approval from the customers to get these assignments. Assignments in the sense data sets and business problems. Okay, so let us earn it. Okay, maybe 1 week after the last working day we'll put that, and then we should be good if I'm not mistaken on this. All right, all fair. Okay, done. So let's proceed further. So once you have the tweets extracted, you're going to read the tweets. When I say read lines, file.choose, file.choose, and then if you open and close the brackets, it will open a pop-up window and you can read all the tweets from that. Once you read the tweets, there is something called a string R. String R is simple, consistent wrappers for common string operations. And then we also have something called as TM, which is for text mining. And NLP stands for natural language processing. Okay, and here, this part that you have, let's see what it's going to capture. There is something called as regex. Is this one? Yep, regular expressions. And then when I put it in this way, see what it has done. It has highlighted all the spaces. And not just that, this will also capture, um, you know, the special characters if you have any. Okay. And then it is going to replace all that, those special characters with a space if you want to. So you're taking X. What does X contain? All the tweets that Sachin Tendulkar has tweeted. You're taking all of those. You're saying string replace all. Taking this all the tweets, you're looking at all the special characters and then you're replacing it with blank space. Once you're done with this, you take this, and each tweet is called as a document. Okay, and collection of all the documents is called as corpus. Okay, collection of all the documents is called as corpus. So you take the corpus and you convert that into a vector format. Vector format means bunch of characters, that's it. And you store it in x1. Now what you're doing, you're using tm underscore map, which is a function which is used to do data pre-processing. So you take x1 and you convert that to lowercase. Okay, and then you take that result and remove the punctuation marks. I selected only E, that's why it was throwing an error. Then I'm going to take the end result and I'm going to remove all the numbers. Then I'm going to take this, which is cleansed now. I will remove all the words, but what words do you want to remove? The stop words from English language. What are the stop words? That should be your question. Obviously, I'm going to show you now on stop words. So these are all called as stop words. You'll get it from English dictionary, by the way. Yeah, you need not worry too much. All these are stop words. You can just Google out and then download, but these things will be uploaded on a learning management system, not to worry. So you remove the stop words and let me run this from the English language. And then each time you remove a punctuation mark or remove a number, for example, say house number 201, there's a special character, these numbers do not make sense. So when you delete it, if it says like this, flat number, and if it says my home jewel apartments in this way, then whenever these are removed, it will create a blank space, a white space, additional spaces. These additional spaces should be removed, only then it will become flat my home, right? In that way there'll be one space, otherwise there'll be a lot of spaces. So when you say that strip white space, it would remove all the additional spaces that you have. And then you generate a word cloud, library of word cloud. And you're saying here that if a word is referred to minimum, say 5 times, only then use it. If the words are used only once or twice, why do you want to use that? Okay, you don't want the words in a random order. You want them to be in a sequential order, and you want all the words to be in blue color. Look at that word cloud. So what's happening here? Sachin Tendulkar is using thanks, thank, wishes. Yeah. Majorly, Sachin Tendulkar uses Twitter to only wish people. And, thank them. And always he's speaking about happiness. If you take this guy, he will never resort negative things. He's always about tweeting happiness. Okay, we can also, you can remove this simple. You go find the actual Twitter. Let me go to this and see. Let's do it without any political inclination, right? We need not have any political inclination. How much ever we disagree, ultimately, since he's prime minister of a country, that's okay. Political views may differ, but just because I'm using this doesn't mean I'm inclined towards Narendra Modi. Yeah, please don't think in that way. And okay, we are now extracting the tweets of Modi. And it's taking a while. Probably when I say he, probably his secretaries would be tweeting it. So it is, maybe there are more tweets, right? So we are extracting all of those, and I'm going to load these tweets, read those, and let us build a word cloud. I don't want to install this, and let's see on what kind of, what happened. Something has gone wrong, I think. Let's see. We mourn the loss of US Congress, passing of Sheshadri, speaking in the English segment. Okay, so I think these are all in the Modi's tweets only. So let's run line by line. Majorly seems like Modi also is tweeting on similar lines, or let me do one thing. Maybe it's not giving the right picture. It is not maybe replacing. So I would do one thing. I will go to downloads, and let me first of all delete these tweets. Okay, it wasn't getting written because I think we had this open. That's the reason. Yeah, now I understand. This was open, so it wasn't getting replaced at all. That's what I was wondering on why. Okay, anyways, I think this should work. So we are extracting the tweets of Modi. You can do anything. You can also extract the tweets of Jagan, of Babu, Chandrababu Naidu, any tweets, doesn't matter. Or any product, or any, celebrity, Amitabh Bachchan, or whatever be it. You can do that. Let me see. Yeah, look at that. I think data cleansing is not proper, but he's speaking about people, he's speaking about COVID, he's speaking about fighting. Okay, he's speaking about India fights Corona, right? So in that way, too many things off late are related to these things. But this you, I really don't know what those are. Maybe we have to do proper data cleansing. Okay. So now hopefully you guys understand the importance of having an account, okay, which will help you all do better job, do better. Okay. Now we are going to spend some more time in understanding about natural language processing, and then I will resort to neural network and how we use that. Welcome to natural language processing. Now, introduction to NLP. Um, Text analytics is a method of extracting meaningful insights and answering questions from text data. But NLP is a touch different. NLP is not just restricted to text data, It also includes speech data. Speech is also included in the purview of natural language processing. And in the broad spectrum, where do and where does NLP stand? Okay, we also need to know about that. So if you want to know about that, NLP is natural language processing. And when you look at your artificial intelligence, okay, let me put it in this way. Say you have your AI. This is your artificial intelligence. And within artificial intelligence, you have data science. Within data science, you would have data mining. Within that data mining, you will have machine learning. Within machine learning, you have deep learning. Within that, you have reinforcement learning. Okay. And where does NLP fit in to this big picture? So I will have to draw another plot to explain you all on where NLP stands, right? NLP is something which falls under linguistic. It cuts across all of these, and NLP is part of linguistics. Combination of AI and combination of this linguistic, here is where you'll have NLP fitting into picture. And within NLP, once again, there is something called as NLG, which is natural language generation. Okay, and there is another thing which is called as NLU. NLU. Okay, you have NLU and NLG, natural language understanding in some sense, right? So let me plot this, or let me go here. Natural language understanding is NLU. What does this mean? What do you mean by NLU? NLU is a process by which an inanimate object means something which is not alive, something which is dead, like your machines, systems, robots, etc. Okay, so a process by which an inanimate object with computing power is able to comprehend spoken language. So when humans speak to robots, robots will understand and they will act accordingly. For example, if you say, open the door, when you give a voice message, open the door. If the door's open, that system is opening the door by understanding your speech, right? And there is also another thing called as NLG, natural language generation. Here, everything is the same. That means this is also a process by which an inanimate object, meaning something which is not alive, like machine systems or robots, with some computing power, is able to manifest its thoughts, meaning it will understand your its thoughts, and then it will put forward its thoughts in a speech format to the human. For example, if the robots, you talk to the robot and robot acts, robot doesn't do anything, it will take instructions and act accordingly. That's NLU. If the robot tries to understand your text, your speech, And then if it starts communicating back with you, that is called as NLG, natural language generation. Okay, it's called as NLG, natural language generation. These are the two broad things within the scope of NLP. Now, before you process the data and before you do anything with the data, you need to understand about certain pre-processing steps. And the first thing here is called as tokenization. Tokenization refers to the process of splitting a sentence into its constituent words. And usually you have three types: unigram, bigram, and trigram. For example, if I say 360 digit MG training is the best in the industry. If you want unigrams, 360 is one unigram, training is another, is the best in the industry. All of these words that you're saying, each individual word is called as a unigram. For this, if you want to generate bigram, how would that be? 360 digit MG training. This is one bigram. Training is another bigram. Is a third bigram. The best. In that way, all these are called as bigrams or two-word combinations. You can also go with a trigram. Trigram means 360 digit MG training is. This is one trigram. Training is the sorry trigram. Next trigram. The next trigram would be is the best. Right? In this way, you'll have three-word combinations which are formed. If you increase beyond 3 grams, you need an extremely powerful computer. Extremely powerful computer. Usually, I mean, there was a research done a few years back wherein they tried out 4-word combinations, and it has taken 2.8 days to complete this 4-word combination word cloud. Do you know what? The amount of RAM that was used was 140 GB RAM. Wow. With 140 GB RAM, it took so much time. So how much time do you think it takes? If you have 5 words, 6 words, etc. Huge amount of time. People do not have so much of time, energy, and money at disposal. So here, there are also challenges with respect to tokenization. What challenges? If I have a sentence such as, we have an office in United Arab Emirates. We is one word, have is another word, and office in United is a single word. It can be anything. United States of America, United Society, United People, it can be anything, right? Only if these three words are used in combination, it makes sense. If they're used as standalone words such as Arab, right? Arab nations are oil rich. Arab nations follow Islam. So Arab means something else. It is not related to United Arab Emirates here. it has a specific meaning in its own, right? It can be used with different other words. Same is the case with Emirates also. You can say I'm flying by Emirates aircraft. It has nothing to do with United Arab Emirates. So if you have unigrams, the entire context might be lost like this. So these are the challenges. And how do you overcome these? By experimentation. Okay. Whenever you do unigrams, you also have to look at that word in context. Go to the raw data, do a control F and search. And we also have something called as POS tagging, which is called as parts of speech tagging. Process of tagging words within the sentences into their respective parts of speech and then labeling them and then giving them labels is called as pause tagging or parts of speech tagging. This is also called as post or it is called as grammatical tagging. Okay, and you have here NNS. If I say Barani has 300 stocks in Infosys. Here, Barani is a noun. It's a singular noun. So you have, it's a singular noun. If it's a singular noun, you use this. Where did that go? NNP. NNP means it's a singular noun. If I say tigers are fighting, okay, tigers are fighting. What is tigers here? It's plural noun. So it will have NNS notation. So this will be given a term NNS. This will be given a term NNP. These notations meaning you're taking your sentence and then you're tagging each of those words with the respective POS and then POS means parts of speech and then you're giving a label to that. For a verb, you give VB. For an adverb, you give RB, so on and so forth. Okay. Another thing that we do is stop word removal. Stop words we already discussed. We have seen that. That's the reason why we have done that exercise so that rest of the things become easy for you all to understand. So you take all of your words which were there in your reviews or Narendra Modi tweets or Sachin Tendulkar tweets and then apply something called a stop word filter. When you apply stop words filter, the words except for your stop words will appear. So all the stop words will get filtered here itself. And then finally you'll have the other words. Next, there is also something called as text normalization. If someone says USA versus United US versus America versus United States of America, all those mean the same. If you say Gurgaon or Gurugram, means the same. UK, United Kingdom. We have our office in Malaysia also. So there you can say Malay language or you can say Bahasa. Both mean the same. These are all the words which are spelled, pronounced, and represented differently, but they mean the same thing. So you need to convert that into a standard format to be able to process it further. For that, there is one thing called as spelling correction. Another thing is called as stemming. The third thing is called as lemmatization. There are three things, okay? Spelling correction, stemming, and lemmatization. So you have three different things which exist. And for spelling correction, it is pretty simple. Like your mobile autocorrection. In your mobile, when you start typing, sometimes you might get incorrect entries on similar lines. Okay, you have something called as autocorrect. Autocorrect is a Python library which will automatically correct, okay, the spellings. It will automatically correct the spellings. And you have something called as stemming. Stemming means, say you have ed at the end, for example, played. It removes this and it brings us to the base form, play. If you have swimming, or swimming is a bad example probably. Um, I'll just say dancing. Okay. If there is something called as dancing, this is also a bad example. Sorry. Okay, let me say playing only. That would be better. Say playing. When you have ing, that ing is removed. And when you have probably words ending with ly, lovely, then you remove ly and make it love. Now here, when I use battling, what would happen when you apply stemming? Ideally, according to the stemming rules, what happens is you'll remove this ing. If you remove ing from battling, you'll have battle. This does not have any meaning in English. It absolutely has no meaning. Since it doesn't have any meaning, the process of applying stemming is flawed. You cannot apply stemming. So what should you do then? You apply something called as lemmatization. Okay, you apply something called as lemmatization. What lemmatization does is it is going to go and look at your underlying dictionary. Okay, it will go look at the underlying dictionary and it is going to extract the base form of the word. So if you have battling here, it will look at what is the base form. If the base form in the dictionary is battling, then it will just take battling. It will not do any removal of any words. That's the good part about lemmatization. So people usually prefer lemmatization over stemming. And there's another thing called as data pre-processing. All these are, the use cases of basically using your unstructured textual data. Sometimes if I throw at you bunch of documents and if I ask you to extract names of all the organizations or all the people or all the places, then how would you do? We have done this analysis with respect to Narendra Modi's speech. What we have done is we have extracted Narendra Modi's Independence Day speech and we wanted to look at how many times Narendra Modi has referred to people, how many times he has referred to different places, and what were those places, organizations, quantities, percentages. All these can be extracted from your data. For example, if it says that Sharath purchased 300 shares in Oracle Corp in 2005. Sharath is the name, people. That would be extracted. How many shares did this person purchase? 300. So that's a quantity. An Oracle Corp is an organization, so it will extract this information. And all these things that are extracted can be used for further analysis. There is also something called as word sense disambiguation. All these are very important, my dear friends. Okay, when we start, when you are dealing with textual data, unstructured, this is of prime importance. Okay, now here, word sense disambiguation. A word's meaning depends on its association with other words in the sentence. Two or more words with the same spelling may mean different, for example. And disambiguation is a process of mapping the right meaning to the right word. If you say he can play music, multiple music instruments. Okay, the play here means something else. If you say, dear DJ, can you please play rock music? This play here means something else. If I say, let us play cricket. Okay, let us play cricket. This play also means something else. So you have play, play, and play. Same word, but in different contexts, it means different. All these are the kind of challenges that exist. Yep, and we need to deal with it. Neural network does amazing job. Okay, here is a question for you all. Sentence boundary detection. Method of detecting where one sentence ends and where another sentence begins. So do you feel that if you have a full stop, this full stop marks the end of the sentence, and after the full stop, maybe you'll have another sentence or not, but then does that mark end of a sentence is my question. And I'm going to, where did that go? Yeah, I'm going to poll this question. So poll question to you all coming your way. um, do you believe that full stop marks end of a sentence? Yes or a no? Please can you all respond to this? A few people are saying yes, a few people are saying no. Ah, absolutely. Absolutely, friends. Not always it means end of sentence, right? Yeah, and you gave me the example. If certain times you might use etc dot. For example, you might see example. If it's a time, you might want to say that meeting starts at 9 a.m. A dot does not mean sentence should end there. It's just a continuation, right? Anti-meridian, post-meridian usually should end with dots here. A lot of people do not follow this nomenclature, but usually you need to follow. But whenever you have such dots or full stop, does not mean it is end of a sentence. So is full stop an indicator of sentence stop? Not at all. Think about, post meridian and anti meridian. They're different. Okay, next. When it comes to data cleansing, one way to perform data cleansing is to use regular expressions. So I've already shown you this regex online 101. So you keep changing this. If you just want to select the numbers 0 till 9, all the numbers which are in the range of 0 to 9 gets highlighted. 3500081. This is our address in Hyderabad. But then, yep, you can make use of a library called as text blob, or you can make use of a library called Keras. And Keras is for deep learning. Hence, we would be using Keras. Okay, we'll be making use of Keras. And there are a lot of types of tokenizers. All these. Tweet tokenizer. Look at this and look at how important social media analytics is. Within Python, you have something exclusively for Twitter called as tweet tokenizer. It is capable of dealing with emotions. It will capture the emotions in your text, in your tweets. Expressions of sentiment are captured, right? So, I mean, there is no escaping. Today, you might feel that, hey, this guy is just forcing us create an account. Tomorrow, you'll yourself create, but it'll be too late. By then, all the other fellow professors and lecturers would have gone ahead in their career, right? So, it's the right time for us. We have to clearly differentiate ourselves from the other folks, right? Please create your social media accounts. That is why we are hell bent upon posting the quiz competitions only on social media, because that's an additional thing that we're giving. But that's how we want to bring you guys to social media, right? If you take it in a positive spirit, I think we can together change many things. Okay, and then we have MWE tokenizer, multi-word expression. What happens is, if I say state of the art learning management system is what 360 digit mg has, state of the art should be treated as, I mean, certain group of multiple words that are treated as one entity. So what happens is, this word would be combined using a hyphen. State of the art. So this is going to be treated as one entity. Next thing is regular expression tokenizer. When it comes to regular expression tokenizer, it's developed using the regex 101 that I've shown you, right? Sentences are split based on occurrence of a particular pattern. This is something that we have seen, right? Then white space tokenizer. Whenever you have a space, you will say that, okay, these two are two different words. What is tokenizer? Splitting a sentence into multiple words. How do you logically do it is a question. Sometimes you might have tab. When you type a word, when you type a word in Microsoft Word or elsewhere, when you press tab key on your keyboard, it will generate an additional space. When you have a word and a space and another word, you'll have a single space. But when you press a tab, you'll have a bigger space. Or a new line character. New line character means like this. You'll have a new line character. New line character, this means your text has to move to the next line, right? In that way. Then you also have something called as word punct tokenizer. It is going to split your text into list of characters or digits. Characters means if you have this T, E, X, T, B, L, O, B, all these are different characters. You can split in that way also. Is it really needed? Oh yes, it is needed. I am going to explain you on why that is needed. And then you have stemming, different methods of stemming. All these are very, very important. Okay, we will discuss about stemming, lemmatization, and some kind of feature engineering. Okay, and then a few word clouds, other ways of visualizing your data. And then with that, we would have completed at least the basics, theoretical portion of what is needed for us to proceed further. Yep. So we will get started with text cleansing, but once again, let's take break. It's 12:30 now. Let us be back by 12:40 and we will complete this theory and get started with the deep learning which is used for which is used in handling uh, textual unstructured data. Okay. I'll be on mute until then and we'll connect back. Yep. Hello, everyone. Welcome back. So, yeah, is it? All right. So, data cleansing, stemming, right? Two or more different forms of same word could be treated as different entities, though they have the same meaning. Okay, that's all about stemming. So you have two stemming, techniques which are broadly used. One is called as regex, which is regular expressions. Okay, for example, what this regular expression stemmer does is, if it's playing, it will stem it down to play. Okay, this is fairly simple and straightforward. Basically, there is absolutely no confusion on this front. This is with respect to your regular stemming. But then you also have, you know, you might also have many other things. So simply put, it is taking your word and replacing it with your base form. So there is something called as prefix and suffix. It will kind of try to remove your prefix or suffix. This is one thing. Another thing that we have is Porter's stemmer. This Porter stemmer is the most common stemmer for dealing with English words. I'm not speaking about other languages here. So there are multiple ways of implementing this. Phase one, it does the small following changes. Whenever you have words such as classes, SSES, it is going to replace SSES with SS. So look at this. SSES gets replaced with this. These are all the algorithms which are already defined. If something ends with IES, you can replace it with I. If something gets ends with SS, you retain it. If something ends with only a single S, like place, the single S is removed. This is all about phase one. Then you have phase two, wherein you have a verb ending with ing. Here, if you have remove, okay, and if you add ing, it becomes removing. So what happens is this ing is removed and you replace it with e. Okay, a verb which is ending with ing would get replaced. I mean, it will get removed basically, right? And then if you have removed as a word, it will look at all these things. You need not manually do it, friends. Automatically, your system, your algorithms, your computers will do it for you. How does it do is something that we are discussing. So if you have ed, it will remove this ed. Okay, for example, if you have singing, this ing is removed and you get sing. If there is something called as dressed, this ed is removed and then you get dress. Examples, right? And then you might also have longer stems, international. Okay, so if at all you have such things, it gets replaced by ate. Sometimes it doesn't make sense. Sometimes, but majority of the times it starts making sense, right? If you have IZER, synthesizer, okay, synthesizer. You want to replace this with synthesize. IZER gets replaced with IZE. Then you have something called as terminator. You replace it with ate. Terminate. Creator. ATOR gets replaced by ATE. I mean, people have spent a lot of time for each and every language. If you work with Spanish or German or French or Malay or Telugu, Telugu also, one of my known friend was working on it in International Language University, IFLU, right? International Foreign Language University, something on those lines, which is there in near Osmania University. He was working on that. And for longer stems, again, if something ends with al, you just remove that al. National. Remove this al, it becomes nation. When something ends with able, remove it. Okay, it is eatable. Able can be removed and it becomes eat. This is these are all the various techniques to perform stemming, and stemming's role is to ensure that the words which are of different forms are brought to its base form. And if something ends with ate, you remove ate. These are all the various ways of handling your you know stemming, basically, because the moment you're given words, you first need to perform thorough cleansing and then take that cleansed data further. Okay. And then I'll tell you how neural network or deep learning is so different from the traditional algorithms. We'll understand that also. Okay. And then you have something called as lemmatization, which we already discussed. What lemmatization does is, for example, if you apply a Porter stemmer on the word independence, right? So what happens is, if it's not given here, I'll tell you. Okay. Only a few rules were given there in that previous slide. If you're given independence, your basic stemma would remove this ENC and you'll get independent, right? Independ. Independ as an English term does not really make any sense. Since it doesn't make any sense, traditional stemming techniques are not valid. So hence people resort to something called as lemmatization. Lemmatization uses a vocabulary. It would look at your dictionaries and then it will actually return the base form of the words. That's why it is more preferred, basically. Okay. And you might ask me this question, hey, what is this morphology? Morphology is study of words and their parts, right? A few common morphemes, you call it in that way, are prefixes. You might have suffix and base words. Like uncommon, right? Uncommon. Un is the prefix. In that way, you'll have a lot of words wherein you'll have, suffixes also which exist. Like able, eatable. This able is a suffix. You have a lot of such things, prefixes, suffixes, base words. Study of all that is called as morphology. So what lemmatization does is it uses the English vocabulary if you're dealing with English language, and it analyzes the word's morphologies. It returns the base forms of words that can be found in dictionaries. Then you have another technique wherein you singularize, pluralize the words. Usually what happens is you bring all the words to a singularized format or pluralized format, any one format. Otherwise what happens is if you say men and man, it will start treating these two as two different words, but these two mean the same. If these two mean the same, then you should perform proper data cleansing. Then you have something called as language translation. Language translation means converting from one language to another. Those also can be done, but for that also you need data cleansing to be done. You perform stop word removal, and we have bunch of stop words which we have already discussed, like the, am, I, is, are. All these are the stop words. Having these kind of stop words doesn't really make sense. And then feature extraction. Within this feature extraction, there is something called as extracting the general features from your raw text. You'll be given a raw text, you'll have to extract the general features from that. For example, it could be as simple as counting the number of words is a very basic feature that you want to extract. How many words are there? Polarity. Polarity means, are people speaking positively or negatively? How positive? How negative? That's polarity. And then we also have subjectivity. Subjective words. So, and extracting all these kind of features is called as general features. We've already discussed about bag of words model. Each word will be treated as one single word. And there is another rule which is called as Zipf's law. This Zipf's law says that for a given corpus, corpus is collection of all the documents. The frequency of any word is inversely proportional to its rank in the frequency table. To explain this, I need to resort to something called as TF-IDF, and I'll explain this part, TF-IDF part. So to explain that, I think I need to go back to the text mining example there. Let me go here. Let me say open the most recent text mining. Yep. Let us go here. And I'll ask a question here and let me see how many of y'all will get it right. Question to y'all is, the word keyboard is referred twice by person 50 and the word USB is referred twice by person 70. So, is the word keyboard as important to person 70 as the word USB, which is for person 70? So, let me write it down here as a poll question. Read it carefully and then answer. So here is a poll question. I'll end this, restart, add a poll question. So here is the poll question. So the poll question is simple. Is what is the term? Is keyboard as important to person 50 as USB is for person 70? Note, both of them have referred to the respective terms 2 times. Yes or a no. Now, while you answer to this, I'll go back here and show you this. Yep. Is keyboard as important to person 50 because person 50 is referring to this twice as that of person 70 because person 70 is referring to this term USB twice. Person 50 is referring twice, person 70 is also referring twice. Let's see. Yep. What is the answer? Okay, majority of you all are saying yes in the poll question. Now, the actual answer is, you'll be surprised to hear, answer is no. Why? What happened? What was so different? Let me explain. So here, this word keyboard is being referred to 200 times in these 100 reviews or 100 documents. So on an average, this term keyboard is being referred to 2 times in each document. Okay, on an average, it is being referred to twice. And this person 50 is also referring to this term 2 times. Okay, person 50 is also referring to this 2 times. So this guy is not referring to this term more than on an average. In comparison to on an average, everyone is referring to this term 2 times. This person also referred to this term 2 times. So how different is this person? Not at all different. So it's the same. So this person is referring twice. On an average, everyone is referring twice. So it's only one time as important because in comparison to on an average, it's only one time as important. But let's look at USB for person 70. Person 70 is referring to this term 2 times. But let's look at this part. 50 times this term USB appeared in 100 documents. It's rarely appearing, only 50 times out of 100 documents. So in each document, how many times does it appear? 0.5 times, that is 1/2. Okay, so in each document, it is being referred to only 0.5 times, which is 1/2 times. And here, 70% 70 is referring to this 2 times, meaning in comparison to on an average, which is 0.5, this guy is referring 2 times, meaning 0.5 plus 0.5 plus 0.5 plus 0.5. In comparison to on an average, this person 70 is referring to this 4 times more because on an average only 0.5. But this guy is referring to 2 times. So 0.5 plus 0.5 plus 0.5 plus 0.5. So it's being referred to 2 times. Okay, that's term frequency. Inverse document frequency. Why is it called as inverse document frequency? Because you take all these term frequencies, you have document frequency here, take inverse of that. Inverse of that is 1 by 2. So multiply each term by 1 by 2. If you multiply this by 1 by 2 here, it becomes 1. So it's only one time as important. But when you look at this 0.5, it is nothing but 1 by 2. And inverse of 1 by 2 is 2. So you multiply each term with 2. And you multiply 2 with this 2, you get 4. So it is 4 times important for person 70 in comparison to on an average. This process of taking term frequency, all these term frequencies, and multiplying these with inverse document frequency is called as TF-IDF. Term frequency, inverse document frequency. Okay, so that is what is mentioned here. TF-IDF. Okay, finally, there are a couple of things. Don't worry about that formula. That's related to um, information, basically. Yeah, that's why you need not worry too much about that. But then if you want me to explain, I'll just explain it in terms of information 101. Okay, how many of you will want me to quickly explain that formula which exists there? Please respond. Based on that, I'll take a call. Because if you all are not interested, I might not want to spend time there. But then if you guys really want me to explain, no, explain that. We want you to explain every portion on a jovial note, yeah. But I'm willing to explain. Just let me know. Do you want me to explain that or no? Let me see here. Explain. Okay, fine. So if I were to explain that, then I need to explain you about information theory 101. 101 means basics, okay? Now, if I make a statement such as sun rose in the east today. Today, do you know what happened? Sun rose from the east. If I make such a statement, what is the probability associated with this event? What is the probability of this event occurring? 100%. When the probability is high, the information contained in that would be 0. That means information of an event is nothing but inversely proportional to the probability of that event. Number one. Okay, number two. I'll take another example. If you have ever been to London, what happens is weather in London is usually cloudy. Most of the times it's cloudy. If someone is giving you this information that, do you know what? Today the weather in London is cloudy. Means there is nothing new about this. Probability is, I think it will be 95%. 95% of, we have our office in UK, London, by the way. Okay. So probability of this event occurring is 0.95. So if information gain is inversely proportional, It would be again close to 0 because you're dividing 1 by a very big number, which is 0.95. If you make a statement that, you know what, a baby is born in my community, is this a rare event? Of course, right? Babies are not born on a daily basis in your community. So you will say that probability of this event occurring is probably 1 by 365. One baby in 365 days could be. So 1 by 365 will be a very small number. If you divide 1 by a very small number, information contained in that will be very high. And if I say there was a major earthquake in maybe Hyderabad. Hyderabad is not going to experience any earthquake based on the history. So even if such an event occurs, probability will be very rare, maybe once in every 15 years. Each year 365, 15 years means 15 into this, that number will be very, very, very small. And if you want the information, it's 1 by that very, very small number. Okay. And that would give you information content, which will be very high. In short, the amount of information which is contained is proportional to how rare that event is. If the event is very rare, if the probability is, very small, then information content will be high. Hence, they are inversely proportional. And what we do is that's what is given. N divided by df. Df is nothing but number of documents which has the term. In how many documents you have the term. Okay, n is the number of documents. And usually what we do is information of the event is equal to 1 by probability of event. And I mean, slightly advanced math is needed to tell you on why we take log. Okay, you just take a log. That's it. When you take a log for mathematical calculations for derivatives, etc., it'll become easier. Okay, but that has a different story on why we use log here. For now, just take it because as part of our data science training, we explain all these things in finer detail. It will take at least 3 hours to explain this rationale. Okay, so for now, just remember this. That's it. Some log is taken. Log is taken for some mathematical calculation. It's easier for derivatives and all that. Hence, we take that. That is the logic of PF IDF. And feature engineering. This is also very important thing. Okay, text similarity. How do I decide on whether two texts are similar in format or not? For that, you look at all the terms. Say this is one document A, this is another document. Okay, or review 1, review 2. In that review, different words are used, such as keyboard, then free, then USB. In that way, all the words are used. This word keyboard appears 3 times in the first review. It appears 5 times. I mean, the word free appears 5 times in this first review. The word USB appears none of the times, and maybe battery appeared once in the first review. Then when you go to the second review, the word keyboard appeared once, free appeared 4 times, USB never appeared, and battery appeared once. If I want to look at how similar these two reviews are, review 1 and review 2. If you want to know how similar these two reviews are, then what you do is you simply apply this formula. Cosine similarity. Now, one thing I definitely want to ask here, what is cos 90 degrees and what is cos 0 degrees? Yep, quickly. Trigonometry, my dear professors and lecturers. What is cos 90 degrees and what is cos 0 degrees? Cosine. Yep, absolutely. I mean, who got it right? Yeah, majority of you all are getting it right. So let me tell you, cosine of 90 degrees is 0. Okay. And what is cosine of 0 degrees? Is equal to 1. That's it. That is all you need to know to help me understand, help you all understand this. For me to help you understand. Okay. Cos 90 degrees is 0. Cos 0 is 1. So if one review, say this is review 1, and if review 2 is exactly on top of that, if review 2 is also exactly on top of that, then the angle between review 1 and 2 is 0 degrees. Okay, the angle between these two is 0. 0 means cos 0, which is equivalent to 1. So if you get an output which is close to 1, that means there is more similarity between these two documents. Okay, now say you have review 2 here and you have review 1 here. If you have review 1 and review 2 and if you have 90 degrees, meaning it will be 0. 0 means there is no similarity between the two reviews. There's not going to be any similarity between review 1 and review 2. And how do you calculate it? A dot B means 3 into 1 plus 5 into 4 plus 0 into 0 plus 1 into 0. And that is what is given here, divided by modulus of A means magnitude of that. So what you do is just take a square root of 3 square plus 5 square plus 0 square plus 1 square. You're just squaring all these numbers, 3 square, 5 square, 0 square, 1 square, into square root of magnitude of B, which is nothing but 1 square plus 4 square plus 0 square plus 0 square. When you solve this, you get 0.94. And since cos 0 degrees is equal to 1, 0.94 is close to this. That means these two are very close to each other. That's what you comment. Okay. So text similarity can be captured using cosine similarity, number 1, or it can also be used for Jacquard coefficient, Jacquard's coefficient. To help you understand Jacquard's coefficient, let me take two statements. So let me make statement 1. I like trainer Bharani Kumar. I mean, I'm just making some statement. I need to make some statement to help you understand. That's why, yeah. Statement 2. Bharani Kumar is not a trainer. He is a consultant. And uh, is a consultant, or I'll rather say that is a chief data scientist, because I am really a chief data scientist on 4 companies. Chief data scientist. Now here you look at the common words. First thing is, what are the common terms which exist? Common terms which exist are Bharani, Bharani, Kumar, Kumar. So these two terms, Bharani, Kumar, and trainer. These three are common terms. And then you look at unique terms. Unique terms means terms which do not appear in both the documents. For example, you have I, here you have Bharani, Kumar, trainer. 3 terms, right? Here you have I, then like is another term, then is not a, is not a, he is a chief data scientist. That also, he is already there here, so you will not write it. A is already there here, so you will not write it again. Chief data scientist. So chief data scientist. Save all these terms. Now, common terms are 3 terms and unique terms are 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. So if you want to find Jacquard's similarity, you just say number of common terms divided by number of unique terms. Number of common terms divided by number of unique terms. That is nothing but 3 by 9. And when you do 3 by 9, you get 0.3. That's it, done. Okay. And then we have already looked at word clouds. There are also other ways of, um, visualizing your data, and that is dependency parse tree, one additional technique, named entities. These are all the different ways of visualizing your data. Now, if I were to give you quick recap of what all we have discussed, then I will have to start off by explaining about all these things. NLP comprises NLU and NLG, and NLP is different to text analytics or text mining, number 1. Number 2, you need to understand about tokenization, you need to understand about the challenges which exist, and you need to understand about parts of speech tagging. Then we need to understand about stop word removal. Then you also need to understand about text normalization, which has spelling correction, stemming, and limitization. Spelling correction, you can use algorithms or libraries which exist. Stemming is slightly more rules driven, and limitization is better than stemming in a few cases, because limitization does an additional check of looking at the dictionary to determine what is the base form of the word. Then we discussed about named entity recognition, wherein you extract the people, the place, organizations, quantities, percentages. Then we also have word sense disambiguation. Then you have sentence boundary detection, and then we have tokenization, wherein we have all these 5 different forms of tokenizers. And Keras has a different way of handling these things. When we discuss, I think tomorrow, about RNN neural network, you'll understand it in a better manner. Then you have stemming. There are two prime techniques which are used to perform stemming. One is regex or regex stemmer, another is Porter stemmer. Then lemmatization, language translation, we discussed all that. We discussed about Zipf's law, TF-IDF, why that law comes, right? Information theory 101. Then we discussed about text similarity, wherein you can use cosine-based similarity or Jacquard similarity. Then we have word cloud and other visualizations such as dependency parse tree and named entities. Okay, so these are a few things which we wanted to discuss. Okay, dependency parse tree is pretty simple logic basically, wherein you'll just come up with a tree structure. It's like a tree, dependency tree. And I mean, if you just want me to give you a brief explanation on this, then this is how it would be. Say, Sharat uh, hit a 6, means tree will be like this. Start off like this, and then you'll keep splitting it. So first is Sharat, it's a noun. Next, it's a verb. Hit, verb, past. So you'll have a verb. Again, you split it. Here you have a noun basically, right? Here you'll say it is a stop word kind of, and here you'll say that it's a noun. So giving this kind of a visualization is also something that you can do, which is called as dependency parse tree. And in named entities, what you do is you extract the name entities from the text, such as all the places. And if you say, I went to New Delhi, and from there I went to Agra, from there I went to some other place, Jaipur, then what happens is all these will be in a different color. It'll be in probably orange color. Then all the organizations that in New Delhi, I went to Panasonic office, and then in Agra, there was some other office. Then in Jaipur, I went to maybe Oracle office. So all these will come in blue color, in a different color. So it's just about highlighting different entities that you extracted with different colors. Okay. Now, these things that we discussed are extremely, extremely important for you all to proceed further. Again, just to tell you, NLP has um, NLU and NLG. Next, we discussed about data pre-processing, in which we discussed about tokenization. IZA. Okay. Then we discussed about parts of speech tagging. Then we discussed about stop word removal. Then we discussed about text normalization. Then we discussed about spelling correction. Then we discussed about limitization. Okay. Stemming. Then limitization. Then we discussed about named entity recognition. Then we discussed about sentence boundary detection. Then we discussed about word sense, disambiguation. Then we discussed about different tokenizers, wherein we had 5 different types of tokenizers, then 2 different stemming techniques like regex stemma, porter stemma, right? Language translation. We discussed about ZIF's law. We discussed about TF, IDF. Then we discussed about text similarity, in which we discussed about cosine based similarity, and we have also discussed about Jacquard similarity. And then different ways of visualizing the data, text visualization. Okay. In this, we discussed about dependency, parse tree, and we discussed about named entities. Wow, a lot of ground covered. Okay, and you'll be given quiz question on social media. Please be active. Otherwise, if we give you assignments, right, at a later point of time, how would you know how to do that assignment, right? If you don't have a social media account. So please be active. And one more thing is, uh, yep, attendance link is given to y'all. And please, 2 things. If you want to refer to our YouTube link, open 360digitmg.com, go completely to the bottom, and you'll have this YouTube link. And I request you all to subscribe. It is live. If you see here, it's live. So if you click on subscribe, you would be able to watch all the future videos also. We keep conducting at least 12 to 13 webinars. Okay, there is the answer. And then um, we also have this mind map. Please go to 360 Digit MG mind map. AI and deep learning is there. Please make best use of that. Here we go. All right. Thank you all so much. Attendance link is also given here. There's an additional module, Manikanta. Okay. So additional modules are additional. Yeah. So these are all for your own additional benefit. You just need to subscribe to our YouTube channel, Harshavardhan, and then you'll be notified. Automatically, you'll get a message. Yeah, guys, that's why I'm a little scared to tell you on GitHub and all that, right? I will share. Okay, don't worry. It will take time. As I've told you, it will take its own sweet time. When the time arises, we'll let you know. Yeah. How the table, it's just some random numbers just to help you understand how to calculate that. Subscribing to the YouTube channel is, I'm pinging this on this. You just need to click. All right. Thank you all so much. Have a good day. Bye for now.